Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be learning on the topic chemical families. So, we are still continuing with alkali metals. Previously, we looked at some physical properties of alkali metals. So, for today, we are going to be looking at some chemical properties. We are going to start with some of the chemical properties and we'll finalize these chemical properties in our next lesson. So for today, we'll look at those chemical properties and then we'll tackle a few questions in regards to what we're going to discuss. So one of the chemical properties of alkali is the reaction of alkali with atmospheric air. We know the air is a mixture of gases. We have different kinds of gases in the atmosphere, but specifically we have oxygen, which is the active part of air, and moisture, which we are going to use in our reactions today. So when alkali metals are usually exposed into the atmosphere, they react with the air and also they react with moisture to form metal hydroxide and hydrogen gas. So for example, when any metal reacts with the atmospheric moisture, they form metal hydroxide and hydrogen gas. And then if this metal hydroxide further reacts with carbon 4 oxide, so also carbon 4 oxide is going to be part of it to form hydrated metal carbonate. So the general equation is metal hydroxide reacts with carbon 4 oxide to form metal hydrogen carbonate. For example, if you react lithium with moisture in the atmosphere, you're going to get lithium hydroxide and hydrogen gas. And if you take this lithium hydroxide and react it with carbon 4 oxide in the atmosphere, it's going to form lithium carbonate with a few molecules of water. And the same applies with sodium. If you expose sodium in the atmosphere, it reacts with the steam in the atmosphere, with the moisture, to form sodium hydroxide and hydrogen gas. And then the sodium hydroxide reacts with carbon 4 oxide to form sodium carbonate with a few molecules of water. Potassium also reacts with moisture in the air to form potassium hydroxide and hydrogen gas. And then that potassium hydroxide reacts with carbon 4 oxide to form potassium carbonate and a few molecules of water. So when we look at now specifically reacting with the active part of air, which is oxygen, so they usually burn with a characteristic flame colors. It is important for us to note these colors because we use them especially when we are doing qualitative analysis. So for example, if we look at lithium, it usually burns in air to form lithium oxide and it burns with a red flame as you can see. And the equation for the reaction is lithium plus oxygen to form lithium oxide. You can see the equation is balanced with correct state symbol. Next, we have sodium. Sodium burns with a yellow flame to form sodium oxide as the only product. So, but if it burns in air enriched with oxygen, like with a lot of oxygen or pure oxygen, it forms sodium peroxide, and sodium peroxide is written like this. So it usually burns in a yellow flame, as you can see. Then we have potassium. Potassium burns with a lilac flame to form potassium oxide. So you can see the lilac flame on the image. And then the next property we'll look at is the reaction of these alkali metals with water. So you'll notice these reactions with water are a repetition of what we discussed in Form 1 when we were discussing the topic water and hydrogen, the reaction of metals with water. You can watch out for that video and check it out. So for example, when potassium reacts with water, so the experiment is where you take a small piece of potassium metal and it's thrown or placed in a trough containing a lot of water. So we're using a small potassium metal with a lot of water because it's very explosive, it's very reactive with water. And then the resultant solution was tested with a litmus paper. A litmus paper is a type of indicator, commercial indicator. So what you notice in this experiment is that the metal is going to float on the surface of water because it's less dense than water or lighter than water. And then you're going to hear a hissing sound. This is because of the production of hydrogen gas in the process. And then the metal will melt into a silvery ball, and it is in an explosive manner. This is because the reaction between water and potassium is exothermic. We see that it produces a lot of heat, which is the one that melts potassium because it has a very low melting point. And then the metal also darts on the surface of the water due to the propulsion by hydrogen gas that has been produced. And then after some time, it bursts into a lilac flame. The reason why it bursts into a lilac flame is when the hydrogen explodes, we know that hydrogen gas is being produced, but it explodes in air to produce a flame. This causes also potassium vapor to form a flame or to burn in air. So when it burns in air now, it forms a lilac flame. Remember in the previous property, we said that potassium burns in air with a lilac flame. That is what is happening here. Some of the potassium vapor are catching the flame and they are forming the lilac flame. So after some time, the solution is tested and it is found to be basic. So it turns a red litmus paper to blue, and blue litmus paper will remain blue. The reason why it does so, it's because it is basic in nature, and in this case, they produce very strong base. So when you look at the equation, we have first the equation of the reaction of potassium with water to form potassium hydroxide. And then potassium also reacts with oxygen. This is where we form the lilac flame. And then this potassium oxide that is formed from this reaction reacts further with oxygen to produce potassium hydroxide. If we look at sodium, you notice sodium and potassium sort of behaves in the same manner, but they form different products. So both of them, they usually cut a small piece and place with large container containing water. That is a trough or a beaker. You can use a beaker as an alternative. Then the resultant solution is tested with a litmus paper. So what you notice on the observations is that the metal will also float on the surface of water because it's lighter than water, just like we said in potassium. And then a hissing sound is going to be produced. This is because of the production of hydrogen gas. Then what happens is that in this case of sodium, it melts into a silvery ball. And we see the reason why it does so, it's because the reaction between sodium and water is exothermic, produces a lot of heat, which melts the sodium. Since sodium also has a low melting point, just like we said with potassium. So after that, it darts on the surface of the water due to the propulsion of hydrogen gas, and then it bursts into a yellow flame. This is different from the flame that we got from potassium burning in air. So sodium bursts into a yellow flame, and then the hydrogen explodes into a flame, which causes some of the sodium to burn. That is where the yellow flame comes from. And then the resultant solution, when it was tested with red litmus, it turned into a blue litmus paper. And then the blue litmus paper remained blue. So this tells us that the solution is a base because of the changes that it happened on the indicator. And when you look at the reaction equation, sodium reacts with water to form sodium hydroxide and hydrogen gas. And then we see the yellow flame, where it's coming from. Some of the sodium also bursts and reacts with oxygen to form a yellow flame and form sodium oxide, which further dissolves in water to form sodium hydroxide. So you can see our final product will always be sodium hydroxide and the hydrogen gas that is being produced. So when we go to lithium, is a bit different from the reaction between sodium and potassium. So you'll notice when you place lithium on a trough containing water, it's going to float on the water surface also because it is lighter than water, and it's going to produce a hissing sound due to the production of hydrogen gas, but it is less vigorous in comparison to potassium and sodium that was vigorous. The other one was explosive because it does not melt. It does not melt since the melting point is relatively high, because we said that lithium is a small atom in comparison to sodium and potassium, so it have very strong metallic bonds. So these bonds require very high energy for them to be broken. That's why it does not melt. And then it's that on the surface of the water due to the propulsion by hydrogen. It does not ignite spontaneously, and then the resultant solution is tested with a red litmus paper, which also turns blue. And then blue litmus paper remains blue to tell us that the reaction forms a base which is referred to as lithium hydroxide. So when you look at the equation, lithium reacts with water to form lithium hydroxide and hydrogen gas. And then lithium also reacts with oxygen to form lithium oxide, which reacts with more water to form lithium hydroxide. This helps us to make a conclusion that lithium is least reactive, followed by sodium, and potassium is the most reactive. So the reactivity between lithium, sodium, and potassium increases down the group, and we said it's because of the size of the atom. The size of the atom. So you can see down the group, the size of the atom is increasing steadily, and that affects the strength of the melting point and boiling point. So you can see it's not that easy to remove an electron in lithium, but it's very easy to remove an electron in the outermost shell in potassium. So because of that easiness to lose an electron or less ionization energy to remove an electron in potassium, that's the reason why it reacts more. Like its reactivity is very high, it reacts very explosive. For lithium, it's the nuclear attraction holds the outermost electron very closely, so you require very less energy, very much energy to remove an electron. It becomes very hard. So that's why the reaction is very slow. So let's look at a few questions. So when water reacts with potassium metal, the hydrogen produced ignites explosively on the surface of water. What causes the ignition? So we said what causes the ignition of this potassium is because the hydrogen bursts into a flame. Since we said the reaction is very exothermic, and then this causes the potassium to catch flame. So the potassium also uh, catches the flame, or it gets burnt. So it burns in air in a lilac flame. Remember, initially, this hydrogen bursts into a flame because we said the reaction is exothermic. It produces a lot of heat. This heat not only melts the potassium, but it causes the hydrogen to burst into a flame. This causes the potassium also to burn in with that flame, and then when it's burnt, it's now burnt with a lilac flame. Then we go to question 2. A piece of sodium was put in a beaker containing water. Write the equation for this reaction. So it is sodium reacts with water to form sodium hydroxide plus hydrogen gas. So if we balance this equation, let all be, we will put two here and we put, so it's balanced. Then take the observation made in the above reaction. So we say that the metal is going to dart on the surface of the water, It's going to melt into a silvery ball because the reaction is very exothermic, and then there'll be a hissing sound because of the production of hydrogen gas. So those are some of the observations that you notice in this reaction. So that concludes for us this subtopic. In the next lesson, we are going to continue with some of these chemical properties, and we are also going to see how these alkali metals react with other compounds. See you then.